Welcome to the lesson about the equal segments theorem. In this lesson, we will discuss the basics and fundamentals behind the lesson, the conditions for it, and how to solve essential problems with it. This theorem can be described as if we have three or more parallel lines intersecting equal parts of one transversal, then they will intersect equal parts of every transversal. So let's draw that so we can see this visually. Let's say I have three parallel lines, one transversal goes across it, two parts within those are congruent. Now, every other transversal I draw, even though they might not be congruent to another, will also have equal parts. The parts of each transversal will be equal to each other. Now, let's take a look at a more official diagram to prove this, to show it with some more basics and some other figures behind it. Now, let's look at this. Again, three lines, they intercept equal parts. Now, if lines L, M, and N are cut by transversals T and S so that DE is congruent to EF, how can I go ahead and prove that the left side, the left transversal, BC and AB are congruent? Well, because these are parallel lines, M and N, well, that means angles 3 and 4 can be congruent to one another. I can also go ahead and construct two more parallel lines, these dotted lines, PD and QE, and then two more lines, BD and AE. They're all parallel, and I'm able to make these lines just out of sheer constructions of parallel lines. Now, because these lines are parallel, angles 1 and 2 are also congruent. And because these sets of lines are parallel, I'll now know that angle 5 is going to end up being congruent to angle 6, and that in the above and similar diagram, angle 9 will be congruent to angle 10. Now, with so many pairs of angles being congruent, I can start on the right side. I know that these two small triangles are congruent to one another. These two middle larger triangles are congruent to one another. And lastly, these two triangles on the left are also congruent to one another, which means that their parts, the corresponding parts, AB and BC, have to be congruent to one another as well. Now, we can apply this and apply it a bit more simply just to triangles. Now, I can take a look at a triangle where I have two congruent parts, making this point D the midpoint of CE. And as I look, that midpoint is attached to a segment BD, and B is also the midpoint because it has two congruent parts as well. So this line is what we call the midsegment, and the midsegment is going to be congruent to the third side of this triangle, which leads us to our corollaries. If a line in a triangle bisects one side and is parallel to the second, then it also bisects the third. Conversely, if a line bisects two sides, then it is parallel to the third. With these two theories in mind, we can also then establish that BD, the midsegment, is going to be half of AE. And AE is, of course, our third side. So how can we apply this? There's a lot of ways we can apply this, going frontwards, going backwards. But when I take a look at a problem like this, I have to first look at what I don't have. I only have confirmation that AD is congruent to DB. So I can set those two algebraic expressions equal to one another. So I'll go ahead and write out that 10 minus x is equal to 2x minus 5. After carefully doing some algebra, I know that I get 15 on one side by adding the 5 and 3x on the other, and that x should equal 5. Now I can go back and plug 5 in, and I'm going to get that BE is 6. Now, if this were indeed a midsegment, this would also be 6, but I would perhaps need some more confirmation to go from there. So let's take a look at a few other problems. Given this problem, I want to find the measures of angles A, B, and C if I know that that line P is parallel to AB. So this line may not act like a midsegment, but it will act in some way to give us proportions, to give us angles. So if I'm trying to find angles, I know that x, the angle at the bottom, and 2x minus 7, plus some quantity is going to give us 180. What I do know, since those lines are parallel, 98 and 82 will be the linear pair, and that bottom angle will also be 82, so I can plop that right into our equation. After doing our algebra, I'll know that I'll have 3x plus 75 will be equal to 180, and I can continue from there. I get 105 on the right side, and that's going to be equal to 3x, so my x is equal to 35. Before I stop, I want to make sure I remember that the point of the problem was to find angles A, B, and C. So angle B is 35. Angle C is going to be 63 because we already knew angle A was going to be 82 because it was corresponding. Now I want to go to my last problem and go ahead and find the measures of angles 1, 2, and 3, and then the length of DE. So I can automatically know that since these sides are parallel, I can establish that both of these corresponding angles will be 26. And then I can go ahead and take a look. Since I'm being told that AB is congruent to CB, I do get an isosceles triangle. So angle 1 plus angle 2 plus 26 degrees will be equal to 180. Angle 1 and angle 2 is then equal to 154. And since angle 1 and 2 are the same, angle 1 is going to be half of that. So my angle 1 will be a simple 77. And if angle 1 is 77, well, angle 2 has to be the same at 77. So now I'm looking for angle 3. Since angle 2 and 3 are corresponding, if angle 2 is 77, then angle 3 must also be 77. And finally, DE is 7 because it is half the third side, which was 14.